Alrighty, welcome back, boys and girls. It's your man, Math Man, Mr. Shank, coming to you live from Summit Academy. In this video, work on unit number 7, lesson number 3. Still working with those exponents, and what we're going to be trying to do today is we'll be able to explain and use a rule for raising a power of 10 to another power. So we're going to say, first off, kind of a little bit of review. It says, what is the volume of a giant cube that measures in 10,000 kilometers on each side? So what we can do, write that volume of a rectangular prism, but because each of those sides are the same, we can write it like this. So we're going to say the length times width times height is going to be the same as 10,000 times 10,000 times 10,000, which is the same as writing it like this. So in the previous lesson, we talked about how changing the expanded form into the exponent form, it's almost like you're counting those zeros. So we're going to say it's going to be 10 to the 4th power times 10 to the 4th power times 10 to the 4th power. And anytime we have that same base, when we're multiplying those together, we can add the exponent. So altogether, this is going to be equal to 10 to the 12th power, which, if we expand it out, that's going to be, so let me say kilometers cubed, or you could say this is equal to, let's say, and count 12 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then every 3 is where you want to put that comma. So we're going to say kilometers cubed as well. So either of those answers would work out. So again, make sure when you're multiplying the same base, you're going to add those exponents together. All right, so something new for this one. So now what we're going to talk about is what happens when we taking powers of a power of 10. So this is when we are raising, something with an exponent already to a new exponent. So it gives us the first one. It says 10 to the 3rd power in parentheses squared, meaning raised to the 2nd power. So it's like we have, one group of 1, 2, 3. So notice how it's almost like it's doing 10 to the 3rd power times 10 to the 3rd power. It's because each of these has 3 of those 10s in it. And then we have 2 of those groups. So altogether, again, if we multiply those exponents, multiply the exponents. So instead of adding them together, we're going to multiply. So we do 3 times 2, which is going to be 6, which is why there's in total 6 of these 10s. Similar idea, we have 5 groups of 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all together, that means we're going to have 10 to the 10th power. So make sure, let me actually change that color a little bit for that one. We do pink here, it's like 10 to the 10th power. All right, so let's do another one. Let's say, okay, well, how many groups do I have? I have 1, 2, 3, 4 groups, and inside of each of those groups is 3 10s. So I'm going to say 10 to the 3rd power with the exponent of 4, because we have 4 of those groups of 10 to the 3rd power. Multiply those exponents together, so we're going to say it's going to be 10 to the 12th power. Now we have to expand it out. So what I'm going to do is I'm going to say, all right, I have 2 groups of 10 to the 4th power. So I'm going to say in parentheses, I have 10 times 10 times 10 times 10. So that's one group. And we do a second group of the same thing. And so all together, how many do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say 10 to the 8th power for that one, because 4 times 2 is 8. So just make sure you multiply those exponents together. And for this one, that last one, there's way too many in here, so we're going to say expanded form is too long. And so what we're going to do is we're going to say just multiply exponents. Just multiply the exponents together. Let's try that again. So again, we're multiplying 8 times 11, and so we're going to say 10 to the 88th power. There we go. Which would have been way too many 10s to try to fit in that little box, so that's why I can skip that one. And so now it says for number 2, it says use those patterns you found to rewrite 10 to the m power all to the n power as an equivalent expression with a single exponent like 10 to the blank power. So what we're going to do is similar to what we did yesterday. We're going to write that general form. So what we can do, we're saying 10 to the m power inside parentheses to the exponent n is going to be the same as 10 to the m times n power. So make sure you multiply them. We could say because there are n groups of m factors that are 10. So make sure you can, write that for yourself. Again, you're raising that value inside the parentheses to a new power, but you can just multiply those exponents together. Moving on to number 3, it says if you took the amount of oil consumed in 2 months in 2013 worldwide, you would make a cube of oil that measures 10 to the third power meters on each side. So on each side. It says how many cubic meters of oil is this? And then do you think this would be enough to fill a pond, a lake, or an ocean? And so what we could do is this. We're going to say this one, we're going to say this. Let's try that again. This is 10 to the 9th cubic meters of oil because we can say, if we wrote it like this, 10 to the third power raised to the third power is going to be the same as 10 to the 9th power, because we're saying, similar to how we did the volume before, we are multiplying itself 3 times. We could say this could fill a lake. So it's a solid amount of oil used. Then for the next part, for number 3, it says how do the rules work. So it says Andre and Elena want to write 10 squared times 10 squared times 10 squared with a single exponent. It says Andre says when you multiply powers with the same base, it means you add the exponents. So 10 squared plus times 10 squared times 10 squared is the same as 10 to the exponent 2 plus 2 plus 2, which is equal to 10 to the 6th power because we add those together. So what we are going to say for this one is actually good. So we're going to say for this one, Andre uses the rule for multiplying values with the same base, uses it correctly. So that one's good because when you, if you expand it out like that, it's almost like you're adding those exponents, so that looks good. Then it says, Elena says 10 squared is multiplied by itself 3 times, so 10 squared times 10 squared times 10 squared is the same thing as 10 squared to the third power, and then she has that's equal to 2 plus 5. or sorry, 2 plus 3 equals 5. So it says, do you agree with either of them? And we can explain it. So we're going to actually say for this one, for mainly Andrea, or sorry, for Elena, we can say this. We can say Elena is partially correct because 10 squared times 10 squared times 10 squared is equal to 10 squared to the third power. But the main issue is she did not use that rule correctly. But she did not use the exponent rule correctly. And we can say what it should have been is this. So it should have been this. It should have been 10 squared to the third power is going to be equal to, not 3 plus 2, it's going to be 2 times 3. So we get 10 to the exponent 2 times 3, which is equal to 10 to the 6th power. So it should have been this instead. All right, so now moving to the bottom, trying to do a little bit of practice here. So it says, write each expression with a single exponent. So again, make sure you're remembering when we're talking about, we have our base, in parentheses, and we have our exponent as a reminder. So I'll do this first one, and I want you to do the others. So for this first one, it says 10 to the 7th power raised to the 2nd power. So we're going to do 7 times 2 to get 14. So do 7 times 2. So we can say that's going to be 10 to the 14th power. So what I want you to do is pause for your turn and check with me. All right, moving to the back now, it says you have 1 million number cubes, each measuring 1 inch on a side. For part A, it says you stack the cubes on top of one another to make an enormous tower. How high would that tower reach? Let's try this one out. So let's say the height, this one's real simple, the height of the tower would be 1 million inches. Which is the same thing as saying 10 to the 6th power inches. So that's how tall it's going to be because you just stack them on top of each other. Then for part B, it says if you arrange the cubes on the floor to make a square, would the square fit in your classroom? What would its dimensions be? So let's try for this one. Let's say the square would be 1,000 inches on each side, which means, or we could say since 1,000 times 1,000 is equal to 1 million. We could say lastly, this would not fit in the classroom. Probably need a very large gym or something like that to be able to fit that size of a square in there. And then lastly, it says if you layered the cubes into layered the cubes into one big cube, what would the dimensions of the big cube be? So we could say lastly, let's do pink, and let's say the cube cube would be 100 inches on each side, since 100 times 100 times 100 is equal to 1 million. So notice how, we use those exponents to be able to guide our answers, but we can also use those expanded form to find out our answers as well. Moving on, it says an amoeba divides to form 2 amoebas after 1 hour. Then 1 hour later, each of the 2 amoebas divides to form 2 more. And it says every hour, each amoeba divides to form 2 more. So it's almost like we're saying this, it's almost like we're saying we have 2 to the power n for this. And so what we can do, says for that first one, how many amoebas are after 1 hour? So what we do is we say 2 to the power 1, which is the same as just 2. Then we can say for the next one, we can say 2 to the power 2 is equal to 4, so we have 2 times itself. And what about when we keep going and we increase it, we do 2 to the 6th power now is going to be equal to 64 because we expanded out. And if we keep going, I'm going to use a calculator for that one, so let me pull up Desmos to be able to show it. Let me push that to the side, push it like right here. Or actually I can put it, I'll put it right here, we'll say. Something like that. All right, so what we want to do is in your Desmos calculator, again, have 2, again, hit that keyboard button. You can say that back so that way you can see it. So we need to use that exponent button. So we need to say squared is going to be 4, and we said 2 to the exponent of 6 is going to be 64. And if we try to do the next one, we're going to say 2 to the power of 24, which is a very large number, is going to be that number there. So make sure that you can use that Desmos calculator carefully for yourself. So make sure you can use it and expand it out. So I'm going to say for that last one, it was 2 to the power of 24, which was a very large number, 167,77216. And then it says, why might exponential notation be preferable to answer these questions? Meaning, again, this is going to be, this right here is exponential notation. So what we can say is that last part, we can say, I personally prefer exponential notation for these large numbers because it is notation. I'm going to try to write that again. Notation is simpler to write compared to large expanded numbers. So instead of having to write it out like that very large form, we can just write it as an exponent. It's a little bit easier. And lastly, it says Elena noticed that 9 years ago, this is a review questions from our systems. It says Elena noticed that 9 years ago, her cousin Katie was twice as old as Elena was then. Then Elena said, in 4 years, I'll be as old as Katie now. So if Elena is currently E years old and Katie is K years old, which system of equation matches the story? So a couple things we want to underline here. We're going to say 9 years ago is an important detail. I'm going to say Katie was twice as old. And then we can say the next part, the next equation is going to be in 4 years, I'll be old as Katie. So we're going to say for this one that it's going to be actually D for that one, because if we look at what we have, we're saying 9 years ago, and that's going to be Katie was twice as old as Elena was, which we said this was Elena. And then the second equation is in 4 years, which is this. It'll be as old as Katie is. That one's a little bit tricky, but as long as you can set it up carefully for that certain situation, it'll be totally fine. And then lastly, for that exit ticket, it says here are some equivalent ways of writing 10 to the 4th power. So it has 10,000 because it has 4 zeros. It has 10 times 10 to the 3rd power because you would add those exponents, or you could write it in that set of parentheses to 10 squared to the 2nd power. So then it says to write as many expressions as you can that has the same value as 10 to the 6th power. And it says focus on using exponents and multiplication. So try, again, make sure you're writing it like this. Again, 10 to the power m in parentheses to the power n is equal to 10 to the power m times n. So make sure that you're using to multiply the exponents. So be sure to ask questions as they come up. And as always, super slam that subscribe button.